Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this is the video that covers chapter 4, numerical methods. Okay, so at first we will be looking at solution of non-linear equation. Okay, so for a non-linear equation, let's say we want to find the roots of non-linear equation. Let's say we have a graph of x and y axis, and the graph has a roots intersect the x-axis at y equal to 0, and the root is where the graph intersects the x-axis at this point. And okay, then we label the intersection as alpha, and we can say that the roots of the graph lies in between two coordinates. Then the coordinates is written as a and b. Okay, so this is the graph of y equal to fx. Okay, then the point for graph A is when we input value of A into the graph, it gives us the value of FA. And meanwhile, if we input point P into the equation of the graph, so then we will have here the point of y that is equal to FB. Okay, so if the graph does have a roots that crosses the x-axis, so therefore we can say that the roots lies in between point A and B. Okay, so there are two methods to solve for the graph, to find the roots of the graph. The first method is to solve it by using graphical. Okay, so let's say we have a graph. I have to draw the graph first, and this is y and this is x, and we have a graph that shaped like this. So from here we can see that the graph crosses the x-axis at point, we call it as alpha, and from here we need to observe the graph and choose the nearest integer on the right and left of the alpha. So it will be labeled as A and B. Okay, so we choose A and B as the nearest integer on the right and left of the alpha. Okay, I will write that down. A is the nearest integer to the left of alpha, and B is the nearest integer to the right of alpha. Okay, so that is how you find the roots of a graph by using graphical method. Okay, then before that you can also apa yang before that maksud saya sebelum kita proceed ke seterusnya lah. Okay, we can mention that the root of the graph lies in between A and B. Okay, you can write it down like that. Alright, so let's look at another example for graphical. Okay, let's say we have a graph where the function is, the equation of the graph is fx equal to f capital X plus gx. So that means there are two types of function inside one function, that is will be equal to 0. Okay, so in order to find the roots of the graph of this function, we can separate the function of fx and gx. Okay, then we can write it down like this: fx equal to negative of gx. Okay, so then from here we can individually draw the graph for fx and the graph of gx. Okay, let's say just for an example, let's say this is the graph. This is the graph of y equal to fx, and this is the graph of f y equal to negative gx. Just for an example, we will be looking at this. Okay, notice that when we write two equation of function together like this, fx and gx, it means we write it down as y equal to y. So this is one of the method that we use to find the point of intersection between the two graphs. So means when we write the equation like this of fx and gx, means we are looking for the intersection points for the graph of fx and gx. So when it means that the intersection here will point to the roots of function fx. So this will be the point of alpha. Okay, so that is the first step. Okay, you separate the two equation of the graph into fx and gx. Separate is to left and right side, and draw individually each of the graph, and then the intersection point between the two graphs is the roots for the initial fx. So it will be marked as alpha. So the interval of the roots will be mentioned as a on the left and b on the right. So a and b is still the same thing, where a is the nearest integer to the left of alpha and b is the nearest integer to the right of alpha. Okay, so from here we can mention that a and b is the interval where the root lies. Okay, di mana root equation itu berada. Now let's look at an example of solving a function by using graphical method. Okay, so this is the question. Show that by sketching that the equation exponent to power 2x plus 4x minus 5 equal to 0 has only one real root. Find the unit interval where the roots lies. Okay, tulisan buruk sikit lah, tapi masih boleh dibaca. Kalau susah nak baca, pause dulu, baca satu-satu. Okay, macam saya cakap tadi. Now let's look at the equation. We have exponent 2x plus 4x minus 5 equal to 0. Okay, if we look closely, we can see that this is one function and this is another function. So just like before, as I said, we can separate the function into two types of function. Bring one to the left and right of the equation. So then we have exponent of 2x equal to negative 4x plus 5. So on the left side we have exponential function, and on the right side we have linear equation. So we sketch each of the graph individually. Let's first sketch the graph. Okay, for exponent to x, the graph will be shaped like this, where it intersect at y equal to 1. So this is the graph of exponent to x. And meanwhile, for graph exponent negative 4x plus 5, so the y-intercept is at 5 and has negative gradient. Okay, so has negative gradient. So this is the equation of graph. That is y equal to negative 4x plus 5. Alright. Okay. So in order to find the intersection right here, we can substitute as y equal to 0. So y equal to 0, negative 4x plus 5, and x is equal to 5 over 4. So this is the point of 1.25. So but that is not the root of the equation. Okay, the root of the equation of the main equation, okay, the exponent of 2x plus 4x minus 5 lies at this point, the point of intersection. So this is the alpha, the roots of the graph. So what we need to do next is to find the interval between this alpha. Okay, so it means we have to find the left and right of this alpha. Okay, as we know, the on the right side of the alpha we have 1, because this is 1.25, so this must be 1 right in between alpha and 1.25, and between 1 we have 0 right over here. So from that information, we can say that the root of the equation lies between the interval of 0 and 1. Right, for algebraic method to find the roots of equation by using algebraic method is, first you need to do it by trial and error. Okay, what is mean here by trial and error? So the trial and error is the way to determine the value of a and b of the equation. A and b on the graph, not of the equation. Okay, let's say we have a graph like this, shaped like this. Okay, so the alpha is where the graph intersect or touch the x-axis. So this is the alpha. So as we already know, the a and b will lie on the left and right side of the alpha. So by that we can mention the interval of the roots. Okay, so as the same thing that I drew before, I draw to you one more thing lah. So this is FA and this is FB. Okay, as you can see, when we input the value of a into the function, what we get is that we get a positive value of y. And meanwhile, if we substitute the value of b into the function, what we get is we will get a negative value of y. So second is FA and FB have different sign. Okay, first you need to do by try and error, and second, when you did the try and error, what you get is FA and FB have two different sign. So by that you already have the value for A and B. So then you can mention the interval of the roots. Okay, so let's look at an example right away. So find algebraically, based on the question, find the algebraically, the unit interval where roots of the equation x cubed minus 4x equal to 5 lies. Okay, first we need to do it by trial and error. Okay, let's try substitute f1 1 into the equation. So then we have 1 power of 3 minus 4 1 minus 5, and this will give us negative 8. So negative 8 is less than 0. Okay, then we need to find another value that must be opposite to negative, means we have to find a positive number, and we try with value of 2. So then 2 power of 3 minus 4 2 minus 5, and we get negative 5. So that is still less than 0. That has the same sign with f1, that is negative and negative. Then we try f3. So f3 will give us equal to 10. That is bigger than 0. So what we have here is that we have already got the value for A and B, that is 2 and 3, because these are the interval where the alpha lies. Okay, so then we can say that the interval is between 2 and 3, because the negative 5 is a type of negative and positive 10 is a positive region. So there is two different signs. Let's look at one more example. Show algebraically that the root of the equation 2x equal to x power of 3 lies in the interval 1.3 and 1.4. Okay, right here they already mentioned the interval, and the given is in the form of decimals, but that never mind, we just follow the question. Okay, so we take the function that is 2x equal to x power of 3, and we rewrite it as fx equal to 2 power of x minus x power of 3. Okay, so then we substitute the value of 1.3 into the function. 1.3 equal to 2 power of 1.3 minus 1.3 power of 3. So that gives us 0.27, and for function 1.4 equal to 2 1.4 minus 1.4 power of 3, and that gives us negative 0.10. Okay, we can see here that 0.27 is bigger than 0, and negative 0.10 is less than 0. So there are two different signs. So it is true that the root is between 1.3 and 1.4. So it is when the two signs are different. Okay, our next example is about show that equation 3 plus x minus 2x square equal to exponent power of x has exactly two roots. Okay, so we have right here is fx equal to exponent x plus 2x square minus x minus 3 equal to 0. Okay, first let's try by try and error. So you can try any number. So let's try with function f equal f negative 1, so that we have exponent negative 1 plus 2 negative 1 square minus negative 1 plus 3. So this will give a value of negative 0.368, that is less than 0. And our next try and error is to substitute function 0. Then we have exponent power of 0 plus 2 0 square minus 0 minus 3, and that is answer is equal to 2. Okay, so from here we can see that negative 0.368 is a type of negative and 2 is bigger than 0, so that is already two different signs. So then we have the root, the interval of the root is in between negative 1 and 0. Okay, so since the equation mentioned that has exactly two roots, so then we need to continue our search by substituting try and error of f1 equal to exponent power of 1 plus 2 1 square minus 1 minus 3. So then we have again negative 0.718, that is less than 0. So right over here it is less than 0. Then this one is once again, oh sorry, right over here is bigger than 0. So right over here is once again less than 0. So another interval for the roots is between 0 and 1. So this is the interval of roots for the equation 3 plus x minus 2x square equal to exponent to the power of x. Okay, then our next example is use graph show 2 power of negative x equal to x power of 3 plus 3 has positive roots. Okay, first I want to mention here that this question requires us to draw a graph that according to the exact scale. So this is not a sketching, but we just show you the example. Okay, we have a function right here is 2 power negative x equal to x cubed plus 3. Okay, then we draw the graph. Okay, we separate the graph into two individual graphs. I mean, separate the function into two individual graphs. So our first graph is the graph of 2 to the power of negative x. So the graph of 2 to the power of negative x shape like this, where it intersect at 1. So this is y equal to 2 to the power of negative x. And another graph is shaped like this, that is x power of 3 plus 3. Okay, so this graph intercept at y equal to 3 and has x-intercept at cube root of negative 3. So then the cube root of negative 3 is the x-intercept. So you press your calculator to find the exact value of cube root of negative 3. So that is where the x-intercept. So the intersection between the two graphs is right here. So this point, according to the exact scale of the graph, this point lies on top of x equal to negative 1. So from here we know that the graph of 2 power of negative x equal to x power of 3 plus 3 has a roots at x equal to negative 1. So let's say if we want to mention the interval of the roots, so the interval will be in between 0 and negative 2. 0 and negative 2. Oh sorry, you can mention it like this, negative 2 and 0.